Okay, right? Don't we discuss about this pure element and non-pure element, but don't pure substances and non-pure substances, but don't confuse substances with the elements, right? Substance is something bigger than an element, so it can be, so some elements can be treated as substances. For example, aluminium is an element and it is a substance as well, right? Anyway, so what is an element? These elements you can't further break down. Like if you try to break down this further, these properties will not be there. So pure substances with definite properties which cannot be further divided by physical or chemical methods. You don't have a way to divide. Simply, you can't divide that. So it is, if you try to divide, still that is, for example, sulfur. So let's divide sulfur, still you'll get sulfur. Copper, if you divide copper, still you will get copper. That is it, right? So these are called elements. But H2O or water, if you divide that, you can get hydrogen and oxygen. So that is not an element, right? That is why even pure water is pure. Even pure water is pure. You can't call that an element. That is a pure substance, but that is not an element. Okay, I hope you got an idea. So this water, pure water, or the other things, we call them compounds. Compounds means, so these compounds are homogeneous, pure substances in which two or more elements are chemically combined in a fixed ratio. So let's make it simple. If you combine elements, two or more elements, more than one element, if you combine two or more elements, right? If you combine two or more elements, so that is called a compound. Compound. Sangyojana කියලා කියන්නේ. That is called a compound. Right? Two or more elements together forms a compound. So H2O or water is a compound. So what about salt? Is it an element or compound? Salt? Is it an element or compound?
Element.
Salt is sodium chloride.
Compound.
Is it? It's compound, right? Salt is sodium chloride. It has sodium and chloride both. So we call that, right? Since there are sodium and chloride both, we call that a compound. Right? Understand this clearly. Compound. Right? Then, okay. So then let's see some compounds. So these are, so you can see iron. Iron, this is actually iron dust and sulfur. So when you mix and heat this until it melts, it will become iron sulfide. Iron sulfide is iron and sulfur both, so we eat, that is a compound, right? This is how compounds are made. So you can see some other compounds. Here, carbon and oxygen together made carbon dioxide. Copper and sulfate together, copper sulfate. Sodium chloride together, sodium chloride. Glucose is like carbon, hydrogen, it forms glucose format. And calcium and carbonate together, calcium carbonate. Sodium and oxygen together, sodium hydroxide. So likewise, sodium, hydrogen, and oxygen, NaOH, right? So this is sodium hydroxide. So let's see. So you can further explore this today. Just go to this ptable.com. So I'll send you the link. Go to the ptable.com website. That is periodic table. It has elements. But in this interactive P table, you have something interesting. So I'll send you the link. In this interactive periodic table, there is something interesting. You can go to compounds here. Can you see? You can go to compounds. And so this part actually still we have not learned. These elements are made up with electrons, neutrons, and protons. Okay, elements are made up with electrons, neutrons, and protons. So there is something called atom, right? So this atomic view. So we will be learning this in future, but for the moment, just don't confuse. Just learn about the properties of these elements and then compounds. Well, let's see how compounds can be made. Let's put hydrogen and oxygen together. I have dragged hydrogen and oxygen, and can you see? So you can see a lot of compounds made up with these combination. Within, like, in addition to that, some other also compound here. Here you can see H2O. It can be ice. H2O, ice is solid, right? H2O, steam, right? Steam is it solid or liquid? H2O steam is, let's put it, steaming. Is it solid, liquid or gas? Steam can you hear me, Pute? Ice is a solid. Steam is Sanidhi. Can you hear me? Sanidhi, can you hear me? Seems something. Right. Tiseni, can you hear me? Tiseni.
Yes, sir.
Can you hear me?
Somewhat.
Okay. So Tiseni, can you tell me, steam, is it solid or gas or liquid? Yes. Steam කියන්නේ දුමාල්ලන්න ගන්න අපි වතුරේ දුමාල්ලනකොට steaming කියලා කියන්නේ. Steam is a gas, right? Then water, is it a liquid, solid or gas? Water is a liquid. Water is liquid. Steam is gas. Ice is solid, right? So you have all three states: H2O ice, H2O like air, and H2O liquid. All three formats are there, and so there are some other formats also. H2O2, hydrogen peroxide, right? H2O2, hydrogen peroxide is also hydrogen and oxygen. And there is something called D2O. D2O is like D2O, same hydrogen, but so this has some different bond. This is called H. This is not H2O. This is heavy water. Here this actually D2O density is little higher than normal H2O, right? So don't confuse with these. Sometimes you might wonder how these things. Okay, so let's see some other. I'm going to mix sodium and chlorine. Yes, chlorine. Here, sodium and chlorine. So it's creating sodium chloride, which is salt, right? Sodium chloride. Okay, so likewise you can, so these are some other things, Puthi. We make it the sodium here, sodium and oxygen and chlorine, sodium hydrochloride, and sodium chlorate is NaClO3, one sodium, one chlorine, and 3 oxygen. Sodium chlorate. Sorry, Puthi.
Can you hear me?
How to get that?
Can you hear me, sir?
Yeah, I can hear you.
Okay.
Okay, so earlier I was asking you a question, but I couldn't hear you. But do you know how to get that? So you have to go to the P table, then drag elements. Let's say you want to drag beryllium and chlorine, and you can see whether that reacts and creating. So you can see beryllium chloride. So you can click on that and learn about this beryllium chloride, how it is made up with, and what kind of solution that is. So how this is used, what are the reactions. Beryllium chloride will react with beryllium chloride will react with H2O, water, and it will create beryllium hydroxide and HCl. So likewise, if you want, you can further study about that, but don't worry, still you are in grade 8. You have time, you can learn about this slowly. Just learn about one first. So there are a lot of elements. Let's learn about one element. Okay. Hydrogen. Hydrogen itself can react with hydrogen. So it will create hydrogen gas. H2, hydrogen gas. Where hydrogen gas is used? Yes, hydrogen gas is used. Haven't you seen hydrogen gas? Actually, you can't see because it is a gas. Hydrogen gas, where it is used? In balloons. Have you seen these balloons which going now? Birthday parties වලට එම අරගෙන balloon එකක් hydrogen පුරවන. ඒක උඩ යනවා balloon. Have you seen that? You can also do that. You can also do that if you use you know that battery has zinc. Battery has zinc. Battery එකක් ඔය පරණ battery වල තියෙනවා zinc. There is a zinc layer in all batteries, right? So take an old battery. So maybe AA or this battery, it has zinc. Inside that, zinc is there. But when you remove the cover, you can see here. So this is, I can hear my voice again. Okay. Right. Anyway, so this is a battery. If you cut a battery in the middle, you can see the carbon rod. This is carbon, right? So here, this is inner zinc case. This is actually covered by zinc. So if you can, right? Then you have like carbon powder and ammonium chloride. Right, that is in the middle. So you can take this zinc case out. You can take this zinc case out. මේ zinc එක අරගන්න පුළුවන්. මේ වටේ තියෙන zinc එක බැටරියක් කපලා පරණ බැටරිය අලුත් එකක් කපන්න එපා. Take this zinc out. So then what you can do, zinc, right? SINK, sorry, SINC. Take the zinc out. Zinc අරගෙන you can mix that with battery water. Battery water is what? What is battery water? Battery water is a compound. So what is made up with? Battery වතුර කියලා කියන්නේ. It's made up with, yes, this is battery water. It is made up with what? Yes. Battery water. Made up with, or made up of, is made up of basically sulfuric acid, right? Sulfuric acid and water. Mixture of sulfuric acid, right? Sulfuric acid basically react with zinc, right? Zinc will react with sulfuric acid. Zinc reacts, pratikriya karna, right? Reacts with sulfuric acid. And what will be created? Here you can see sulfuric acid is 2 hydrogen, sulfur and oxygen. So that will react with zinc and it will create zinc sulfate, and as well as, right, it will here zinc sulfate, and it will create hydrogen. එතකොට ඔයා මේ බැටරි එකේ තියෙන සිංක් කව එක මේක කරලා බලන්න පුළුවන්. පරණ බැටරි එකක් නෙවෙයි, බැටරි පහක් විතර හොයාගන්න. So I'll show you, right? Take all battery and also, right, after taking all battery, so then remove the zinc layer, cut that zinc into small pieces, put battery water or sulfuric acid, then it will create zinc sulfate as well as will emit hydrogen. So this can be done in a bottle. බෝතලයක මේක කරන්න පුළුවන්. You can use a glass bottle. Don't worry, it's not getting hot, and it will emit, right? It will emit hydrogen. You can collect that to a balloon. Right? You can collect that to a balloon. Right? So zinc and right? Zinc and sulfuric acid here. Zinc and sulfuric acid will react and it will emit hydrogen. This hydrogen, you can collect it to a balloon, and this balloon is inflatable. So this balloon will blast if you like don't like keep it closer to a like fire. Don't keep it closer to a fire because that will blast with pop sound. Hydrogen පිපිරෙනවා. හරිද? hydrogen react කරනවා වගේම පිපිරෙනවා. එහෙනම් මේක මේ තියන්න එපා. මේ ලිපක් ළඟ හරි එහෙම නැත්නම් ඔය මේ ගිනි පෙට්ටියක් ඒ වගේ ගිනි කූරක් ළඟ එහෙම තියන්න එපා. Because this will blast. But so this has a special property. Hydrogen has very low density. Therefore, when you fill a balloon like this, what will happen when you like take the balloon out? This balloon will fly. ඔයාලට මේක කරන්න පුළුවන්. balloon මේ තියෙන්නේ අපි හිතමු මේ බෝතලයක් ගන්න. Take a bottle. You can take a glass bottle පුතේ. So then after taking glass bottle, put sulfuric acid and zinc into it and then close this with a balloon. So with the time, slowly this balloon will inflate. මේ වගේ balloon එක හිමීට inflate වෙනවා. මේක ලොකු වුණාට පස්සේ after making this bigger, you can take this balloon and this balloon will fly away, right? Because it has hydrogen. Anyway, so what did I explain now? I explained about solutions and their reactions. What was the solutions? Can you tell me the solutions that I have taken? Right? For this reaction, what is the solution that I have taken? I have taken zinc and then zinc plus what is next? Sulfuric. Zinc or sulfuric, what is the solution? Sorry, what is the compound? Out of them, what is the compound? Is it zinc or sulfuric? Or both? Yes, Pute? මේ වගේ compound මොනවාද? මම දැන් කිව්වා zinc උයි sulfuric වලයි reaction. So what is a compound? Compound means two or more elements. Zinc, is it an element or compound? Zinc?
Element.
Element. So then sulfuric, is it an element or compound?
Element.
Sulfuric is H2SO4.
Oh.
Then is it element or compound? H2SO4. Actually, it says 2 hydrogen, 1 sulfur, 4 oxygen. Is it a compound or element?
Compound.
Compound, right? So it will react and it will create zinc sulfate. Is it a compound or solution? Zinc sulfate? Is it a compound or element?
Compound.
Yeah, it's a compound. And it will emit hydrogen. Hydrogen, is it a compound or element?
Compound.
It's a compound. Actually, hydrogen, you can take that as element also. Hydrogen එකක් ගත්තොත් element පුතේ. But මෙතන ඇත්තටම hydrogen දෙකක් එකතු වෙලානේ හැදෙන්නේ. Hydrogen gas is H2, it is a compound, right? So be careful, right? This hydrogen is element. This hydrogen is a compound, right? Because it is 2 elements. It has 2 elements, 2 hydrogen elements. Right, now are you clear? Do you have like any question to ask about the compounds and elements? Are you clear about the compounds and elements? Compound has 2 or more elements, but element cannot be further divided. Are you clear on this? Or do you have any doubt? You can ask. Is there any? Some?
Yes.
Any doubt? Or is it okay?
No, sir.
Clear, right? Okay, Tisani, what about you? Do you have any doubts? Oh, clear?
Clear.
Okay. right? Then, right, oxygen, nitrogen, argon present in ordinary air are elements, but carbon dioxide is a compound. So in
Excuse me, sir. Excuse me, sir.
yes, Pute, can hear you.
Sir, are you giving writing?
Yeah, I'm normally giving it, but today I'll not give because I have to explain this note and then I'll give the tube, right?
Okay, sir. All right.
Okay, then so you can see these are compounds, right? Compound, copper sulfate, copper and sulfate, sodium chloride, sodium hydroxide, calcium carbonate, carbon dioxide, water. These are compounds. So these are the elements present in there. Copper sulfate made with copper, sulfur, and oxygen. Sodium chloride, sodium and chlorine. Sodium hydroxide, sodium, hydrogen, and oxygen. Calcium carbonate, calcium, carbon, and oxygen. Carbon dioxide, carbon, and oxygen. You can see in lot of elements, oxygen is present, right? Oxygen, oxygen will react with many like oxygen will react with many elements and it will help creating compounds. Oxygen में ගොඩාක් ඒවත් එක්ක සම්බන්ධයි. That is why here sulfate, hydroxide, carbonate, dioxide, water, right? You have oxygen there. Okay, so then let's move to the 4.2.2 various properties of these matter. Right? We have already discussed some properties, but here there are some more. So one is right hardness, and there's another one that is luster. What is that? Like that is like illusion or kind of. This is actually the property where the surface is shiny. It can reflect light. It can reflect light. So mainly this is there in metals, but it can be there in right. It can be there in other also like oil-like thing. But this is basically a property of metal. Hardness, we already discussed about that. Hardness means, so these bonds are so closer. So these are resistance to wear and tear and also stretching. අපිට මේවා මේ ගෙවෙන්නේ අඩුයි, ගෙවෙනවා අඩුයි, හැඩය වෙනස් කරන්න අමාරුයි, සූරන්නත් අමාරුයි. Hardness, that is the property. Brittleness is ability to break into pieces when small force is applied, right? With a small force. So brittleness means it can divide into pieces. Example, can you tell me example having more brittleness? Example. So what's brittle? Yes, can you tell me an example?
Charcoal.
Sorry, sir.
Okay, charcoal is brittle. And what about glass? Easy, right? Easily glass can be broken into small pieces. So that is called brittleness. Okay, then the next is thermal conductivity. What is thermal conductivity? Thermal conductivity, what is that? Luster is one thing. Luster is having like shiny surface, aluminum. So these things are having the surface.
Sir, it is a material. It is a material that is measured with its ability to conduct heat.
Ability to conduct
Heat.
heat. Yes, ability to conduct heat. That means it can transfer heat. Electrical conductivity, transfer electrons, right? Thermal conductivity means ability to transfer heat, but electrical conductivity is ability to transfer electrons and maybe current, you can say simply current එක යවන්න පුළුවන්. thermal conductivity එකෙන් රස්නය යවන්න පුළුවන්. රස්නය උණුසුම යවන්න පුළුවන්. thermal. හරි මේකෙන් යවන්න පුළුවන් current එක විදුලිය electricity. Serenity. What is serenity?
Sorry.
It is kind of sound. So have you like so you know in temples and all, right? In temples, normally in the temples, if you are visiting there, you can see there is a bell that is using the feature serenity here. So serenity is mainly the bells are made up with that. When you hit, right? When you hit it, it can emit a lasting sound. Now, this is very, very good example for serenity. Right? The sound is lasting. It's not like this, right? When you hit your desk, you cannot say that serenity normally, but there's a sound. But this sound is actually lasting sound. Yeah. So think about a bell here. It can make a lasting sound. ගොඩාක් වෙලා තියෙන sound එකක් emit කරන්න පුළුවන්. That is called serenity, right? Okay. Then color. So that you know, right? Visual quality of substance. Gold has a gold color, silver color. We call that a color name also based on the element. Elasticity. So what is elasticity?
It is the pulling and returning to the.
Sorry, Pute. Yes, we can pull or we can provide a force and then change the length, increase the length. Elastic කියලා කියන්නේ. Elastic වල තියෙන්නේ දෙක. We can change the length by pulling actually or providing a force. Right? Then density. That is very clear. Density is Dhanatwaya. It is actually mass of a unit volume. If you take a volume per liter, so what is the mass per liter? Or like you can say, take a unit of, right? Take a unit of volume and you have to measure the mass, that is density. If mass is high, we call high density. If mass is low in particular volume, low density. Malleability. We discussed this already. Malleability. Malleability and ductility. Malleability and ductility. So what is that? Malleability, ductility. Tell me.
Malleability is it is without breaking it into pieces.
Yes, without breaking into pieces, what you can do? කොටස් වලට කැඩෙන්නේ නැතුව කරන්න පුළුවන් වැඩක් තියෙනවා.
Can hammer it into shapes.
Yeah, we can use a hammer and without breaking into pieces, we can make a plate like this. So we can increase the surface area. That is called malleability. Then what is ductility?
We can run a wire without breaking.
We can create a wire without breaking. Without breaking, we can increase the length or make a wire without breaking. That is called ductility, right? Malleability is ability to be hammered into sheet. You can make it flat without breaking. The example, iron. Iron can be, right? It can be hammered and create maybe scissors, knives. These are made with malleability property. Ductility is ability to make wires. You can see there are copper wires. How? Because of the ductility. Smell. So what kind of, like, how we feel?
The sensation.
When you sense using our nose, how it feels. Sensation come to the nose. Then expansivity. Expansivity. Don't look at the note, just expansivity.
Sorry, sir.
Expansivity. Expansivity. What is that?
It is
සිංහලෙන් කිව්වොත් ප්‍රසාරණය කරනවා. Expansivity.
Sir, it is the amount of a material that expands
Yeah,
per
when you
unit
expand,
length.
yes, the volume of the material increase without changing the weight. Neither. Volume increases, increase of the volume, but without increasing the mass. බර වැඩි වෙන්නේ නැහැ. හැබැයි ප්‍රමාණය වැඩි වෙනවා. කොහොමද එහෙම වෙන්නේ? රත් කරද්දි තමයි වෙන්නේ. When you make heat, like when you heat, so that happens. Have you seen there is a gap between this railroad iron? There is a gap. Have you seen the railway?
Yes, sir.
Right, there is a.
Yes.
Yes, why is that? Yes, so there is a gap between here. You can see there's a small gap between, right? So two. Otherwise, what will happen if there are no? So when this heat, when this like when this like when it will heat, right? This will expand. The මේ රත් වෙද්දි ප්‍රසාරණය වෙනවා පොඩ්ඩක්. මේ ප්‍රසාරණය වෙනකොට මේ දෙක ගෑවෙන්න තමයි මේක හදලා තියෙන්නේ. If there are no gaps, then what will happen? එතකොට මෙන්න මේ වගේ ඇද වෙන්න පුළුවන්. හරි මෙහෙම ගැප් එකක් තියලා හදලා තිබ්බේ නැත්තම් මොකද වෙන්නේ? මේක මේ වගේ ඇද වෙලා යන්න පුළුවන්. මොකද එයාට ඉඩ නැහැ ප්‍රසාරණය වෙන්න. එතකොට වෙන්නේ කොහොමද? තද වෙලා මේ දෙක අතර මේ දෙක ගොඩක් තද වෙලා මේ රේල් පිල් ඇද වෙන්න පුළුවන්. ඒ හින්දා තමයි that's why there is a small gap between these two. Right? There is a gap between these two. The reason is the expansivity. Expansivity. Again, can you see the image again? I'm not sure whether you can see this. So tell me when you cannot see, right? Now can you see this?
Yes, sir.
All right. Earlier I think you couldn't see. Here there is a gap. If this gap is not there, it can cause this kind of damages to the railroad. That is why there is a gap between this. But here there's a gap. Here there's a gap between two railway tracks. Gap between the railway tracks. To allow the expansivity, right? Allow expansivity because it can, with the heat, it can expand. It can increase the volume, but it is not changing the mass. Texture, whether the surface is, so how when you touch, how you feel, that is the texture. Is it rough or smooth? Melting point and boiling point. So that we have discussed, but today we don't have enough time. But anyway, just tell me idea, what is melting point, what is boiling point? So what's your idea about this? So I'll give you an example. Boiling point of water is 100 Celsius. Melting point of ice is 0 Celsius. So what is the meaning of this? Melting point, boiling point. Yes, Pute, melting point and boiling point.
Sorry, sir.
So what is the meaning of melting point and boiling point? Don't look at the note. Just give me your idea. Melting point and boiling point.
Melting point is the temperature which a given solid will melt.
Yes, the temperature where this, like when solid is converted to liquid, the melting point is the temperature. So like temperature that happens, the conversion, the state conversion, that is melting point. Boiling point?
And the boiling point is the temperature which liquid boils and turns to water vapor.
Liquid, yes. When liquid become gas, the boiling point is the temperature. What happened in that? Actually, so this is interesting point. This has interesting thing. So there are two activities highlighting the melting point and boiling point here. So let's take ice, Pute. Let's take ice, and you have to create this practical. We have to do this practical. So when you provide heat, normally the temperature is not changing. For a long time, it will not change. It will remain in 0. And maybe the minus decrease, it can raise from the minus decrease, but it will stop at 0. බිඳුවෙන් නැවතිලා හැමම තියෙනවා without changing. අපි රත් කරනවා. අපි කොච්චර රත් කරත් even we provide heat, so it will increase the heat, but it will stop at 0. 0 වල නැවතිලා තියෙනවා වැඩි වෙන්නේ නැහැ. කොච්චර රත් කරත් මේක වැඩි වෙන්නේ නැහැ. හැබැයි ඔක්කොම ice ටික දිය වෙලා ඉවර වෙනකොට after melting all these ice, then water, it will become water. So this is ice. And when it is converted to water, fully converted to water, සම්පූර්ණයෙන් water වලට convert වුණා, then only it increase the temperature. And it will again increase up to 100. Then what will happen? It will remain at the 100. One of the water තියෙනවා, ice තියෙනවා. Ice වල අඩුවක් තියෙන්න පුළුවන්. හරිද? අඩුව වගේම තියෙන්න පුළුවන්. ඍණ ගණන් තියෙන්න පුළුවන් සෙල්සියස්. බිඳුවට ආවට පස්සේ when it becomes 0, until it become water, fully converted to water, it will remain in 0. And then water will start heating and it will raise the heat. Heat එක වැඩි වේගෙන යනවා. And when it is 100 degrees, it will remain 100 degrees without changing. How long it will last? Without changing, it will keep 100 degrees. How long? Until, yes, until when? 100 විදියට දැන් මේක නැවතිලා තියෙනවා. පුතේ 100ට එනකන් වැඩි වෙනවා. වතුර පටන් ගන්නකොට නම් බිඳුවේ වතුර තියෙන්න පුළුවන්. සෙල්සියස් 5 වතුර තියෙන්න පුළුවන්. සෙල්සියස් 20 වතුර තියෙන්න පුළුවන්. සෙල්සියස් 30 වතුර තියෙනවා. සෙල්සියස් 50 වතුර. සෙල්සියස් 60 වතුර. සෙල්සියස් 100 වතුර. After 100, it's not changing. It's 100. කොච්චර රත් කරත් 100මයි. So then what? At this stage, what will happen? It will increase. At one stage, that will increase. But at that time, the entire, so all this liquid water has become vapor or gas. ඔක්කොම වතුර ටික සම්පූර්ණයෙන් වාෂ්ප වෙනකන් වාෂ්ප වල උෂ්ණත්වය ඊට පස්සේ වෙනස් වෙනවා. හැබැයි වතුර ටික වාෂ්ප වෙනකන් මොකද වෙන්නේ? ඒක 100මයි. So this is called boiling point. And this is called melting point. Clear on this? So there are two temperatures. This is where the solid become liquid. Until the conversion process happen, it will not change the temperature. This is where a liquid become gas. Until the state conversion happen, it will not change the temperature. These are two fixed temperatures. Okay, are you clear on this? Hello? Yes or no?
Yes, sir.
Okay. Right, next day I'll be discussing about this melting point, boiling point, density. These are some properties that we need to discuss. We need to do some small calculations on that also. I'll be discussing that next day. Right, we will be, yes, we have to discuss more things like boiling point, melting point. We have already discussed that, but let's discuss more. And also about the electrical and thermal conductivity and different status of different elements. So I think we can finish the lesson next day. Yeah, we'll finish the lesson.
All right, sir.
Okay, then good night.
Thank you, sir. Bye, sir. Have a nice day.
Thank you, sir.
Welcome.